Okay, so today we're working on the OR formula. Okay, so a couple things we need to go over first. We need to go over this notation. Okay, first notation that we're going to go over is subset. Okay, which is the sideways C here. Now, if you think about it, well, if you look at this, so a subset is when there is a set within a set. Okay, so let's pretend the big circle here is your school. So your school's there. Okay. Let's say everybody's in a class within your school. Let's figure out a class that's in everyone's school. That is maybe functions, right? So the functions class is a subset of your whole school, or something within a set. Okay. So for example, if we had set A here, which is numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, set B was the odd numbers. Since all of set B's numbers are in set A, therefore B is a subset of A. That's what's written here. B is a subset of A. Okay? Now, yesterday we went over complement, right? So complement is everything that's not set A. So in terms of, if we go back to the school, right? If this is your school in this set, right? Let's call this school, I don't know, St. Thomas or St. Mary's, but this is your school here. Everybody who's not in your school, I'm going to make that S for your school. Everybody who's not in your school, that is the complement. So S with an apostrophe is the complement. Right now, working towards what we're going to work towards the next couple of days, this is most important. This symbol here means and. Okay, and we worked through it already with our previous one. The and is where it belongs to both A and B. Just remember that's and. The upside down one here is or. Okay, that's one or the other. Okay, one or the other. Now we could have something that's mutually exclusive, where we have two things that don't cross over. Okay, so we could have mutually exclusive A and B, but they don't cross over. Right. Now I would say something along the lines of, let's say this is the football team, and this is girls' basketball team. Okay, so the set of students that are on the football team, there's nobody who's on the football team that's also on the girls' basketball team. So they are mutually exclusive between the two of them. All right. Now this is your OR formula. And let me go back to my other course. I'll show you where I want to put it. There's our OR formula. Okay. So OR formula is right here, across here. So the probability of A or B occurring equals the probability of A plus the probability of B minus the probability of A and B. Right? Now it's mutually exclusive. It has just A plus B because you don't have to subtract the probability of A or B because there's no crossover right here. So there's nothing to subtract. Okay? So pause it here and write those in your formula sheet. You can see kind of where it is. All right. So let's play with this a little bit. Yeah. So back to the note. So we're using the OR formula here. I already did that. I already did that. I don't want to do that. Okay. Let's take a look at this. This is one thing you're going to have to build, is a sum chart for two dice. So we have one red dice and one green dice. So our red dice, we could roll a 1, a 2, a 3, a 4, a 5, and a 6. And our green dice, we could roll a 1, a 2, a 3, a 4, a 5, and a 6. So you can roll any. When I roll two dice, those are all the possibilities. What goes in the middle here is the total. Sorry. If I roll a 1 and a 1, my sum is going to be 2. If I roll a 1 on the red and 2 on the green, my sum is going to be 3. A 1 and a 3 is going to be 4. A 5, a 6, and a 7. Now a 2 and a 1 here is going to equal 3. A 2 and a 2 here is going to equal 4. A 2 and a 3 is going to be 5. A 2 and a 4 is going to be 6, 7, and 8. Right here, we're pretending, or imagine we have a 3 on the red, a 1 on the green. So that's going to equal 4. 3 in the red and 2 on the green is 5, 6, 7, 8, and 9. Now 4 in the red, 1 in the green is going to equal 5. A 4 and a 2 is 6. And we're going to keep going as such. 10. I'm going to go this way. 6, 7, 7, 8, 8, 9, 9, 10, 10, 11, and 11 and 12. Okay? So we need to be able to build one of those. Now, I'm going to copy this because they're going to want to use it again later. Oh, that just popped me to a totally different page. Oh, crap. Let's go back. Copy. Press the wrong thing. Okay. So, if we look here, the question is, and all the questions are going to want to look for keywords. In this case, the question's OR. So we roll two dice, one red, one green. Find the probability a 2 or a total of 12 is going to show up. So what I'm going to do here now is I am going to highlight a total of 2. That's just that one. And then I'm going to highlight my total of 12, which is this one. So if we use the OR formula, so the probability I get a 2 or a 12 equals the probability of a 2 plus the probability of a 12 minus the probability of a 2. Oops, I used the wrong thing. And a 12. Now when I do my sums, there's a total of 36 different sums that could occur. Right? So in this case, the probability of getting a 2, I have 1 2 out of 36. So it's 1 over 36 plus probably getting a 12 is 1 over 36 minus, now, is there any occurrence where I can roll a 2 and a 12 at the same time? No. So these are actually mutually exclusive, which is 0 to 36. So my total is 2 over 36, or there's a 1 in 18 chance I can get a 2 or a 12. All right, so now let's do the next one. A total of 4 or a pair occurs. So a pair and a total of 4. I'm going to try to erase these two. Put that back in. All right, so how many pairs do we have? Pairs of 1 and 1 is a pair, a 2 and a 2, a 3 and a 3, 4 and a 4, 5 and 5, and 6 and 6. So in my probability here, I have 1, 2, 3, 4, 5, 6 pairs. Now, a total of 4 just occurs here and here. So in that case, it's 2. So if I'm using my OR formula, the probability of a pair or a 4 is the probability of a pair plus the probability of a 4 minus the probability of a pair and a 4, which equals, I have 6 over 36 here, plus 2 over 36 pairs, minus, now, do I have an occurrence where a pair and a 4 exist? Yes, I do, right here. So there's 1 in 36 chance they both occur. So I got to subtract those off or I'm going to be double counting. As in, there's a 4 in this one and a 4 in this one, so I'm going to count it twice when it only can exist once. So my total there is going to be 7 over 36. That's the probability of me getting a pair or a 4. So let's do another one of these. Let's do the probability of a sum greater than 5 and the probability of a even number. Okay? So let's see what we got here. So I have my chart now. And I'm going to highlight in yellow all my sums greater than 5. So that's all these numbers here that are greater than 5. Okay, how many do I have there now? 1, 2, 3, 4, 5, 6, 12. Oops, I accidentally did this one. So 6, 12. Let's go this way. 6 plus 12 plus 5 is 17 plus 4, 21 plus 3 is 24. And then plus 2 is 26. Did I get that right? 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Now my even numbers are going to do in blue. So these are all my evens. And there should be half of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there's 18 of those. So my formula here, probability of probability of greater than 5 or even will be equal to probability of greater than 5 plus the probability of even minus the probability of greater than 5 and even. So if I look here, I have 26 over 36 here plus 18 over 36 minus how many times does it both occur? So I'm going to count how many times I have double colors here. So I have 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 over 36. So my total now is 30 over 36 or 5 over 6 chance. Now if you really want to, you could always give it to me as a fraction or a decimal place, which is 0.83, or a percent, which is 83% chance. Those are all correct answers. Okay. Let me see if I can figure one out here. let's say I have a problem where there's 100 students in grade 10. 30 play in the band and 20 play sports, and 10 play band and do sports. Okay, so if I was doing this here, right? So I'm looking for the probability. I randomly pick a person, and they're either in the band or they play sports. So I'm looking at the probability of being in the band plus the probability of playing sports minus the probability they're in the band and they play sports. So in this case, I have 30 people in the band out of 100 plus 20 people who play sports over 100 minus the 10 people who do both. So it's a 40 over 100, which equals 4 over 10, which equals 0.4, which equals 40%. Okay, I put it over 100 because I have 100 total students. Now the other thing I can do here is, what if I told you that, let me think here. What if I told you that 40% of the people are going to prom or they're going to, let's go baseball game. Okay, 40% are going to prom or the baseball game. That would have, I'm just making up these numbers, so hopefully they work. Let's have 30% are going to prom, 20% are going to the baseball game. How many are doing both? They're doing baseball and prom. Okay, so this time, if I'm looking at my formula, I have prom or baseball equals the probability of prom plus the probability of baseball minus the probability of prom and baseball. In this case, I have my OR number. That's my OR percentage. I have my prom percentage. And I have my, should I go? And I have my baseball percentage. So I'm looking this time for this here. So I have a little bit of algebra to do in the sense of, I'm going to swap these two. Right? So I end up with probability of prom and baseball being over here. Now it's positive, is a negative over there, make it positive. Equals the probability of prom plus the probability of baseball minus the probability of prom or baseball. And then we can just plug in our numbers, which is 40 plus 30 minus 20. So that equals 50. So probably getting someone who's going to prom or going to the baseball game, if I were just randomly checking, would be 50%. So I could put any one of these, give you 3 out of the 4, and you just have to rearrange it. Okay? Let's do one more. Do we need one more? I think we're good. There'll be lots to practice. Okay, so hopefully that makes sense to you, and we're good to go.